0, no, -2, +2 maybe. And let's do some testing, show you the build. Just put in this solar panel. It's one of the big ones that we're going to have on our big array. So it's a 425 Q cell, 48 volt. There's my sand. Didn't leave. I have to take the lid off of it. Actually, the handle's holding the lid on. So testing the temperature on this guy. So at 0 degrees outside right now, where the sand is reading 7, 4, 10, 6, all over the place. It just came outside. It was in the garage while I was working on it. So I've got the MC4 connectors joined up, right, as you can see right back there. I screwed up my wires, put the wrong tips on the wrong things, so to remind myself, I got the black tape on the red wire, just to, because that's not correct. I just mixed up my MC4s on my pins, and I didn't want to have to dismantle it. So playing smart, I put in an inline fuse, 10 amp, and then using a 120 volt switch, which is totally safe because I'm only running 48 volts through a 120 volt switch, and amperage coming out of this at high output with the resistance. The hot water tank heating outlet that I use is a 120 volt 1500 watt capable. It runs 10.8 ohms of resistance. So when you take that 48 volt and divide it by the 10.8 ohms, I think it came down to 3.33 amps or 4.12 amps. I think it was 4.12. I don't know, whatever. Something there. It's low amps. So, but that I did a test yesterday just in some 4-liter thing of water, and it had that water heated to 60 degrees at 48 volts off of some batteries, not even off the solar panel at the time, just having the element. Most of it was in the water, and it ended up giving it 60 degrees in, I don't know, about 10, maybe 15 minutes. So it definitely was working. That was my testing. I just seriesed up 4 batteries and did that run. So because you don't ever want to be disconnecting these MC4s directly, because you can't undo them quick enough, and you can jump your arc if you disconnect those when under load. So of course they're under load, they're charging this. So instead what I'm able to do is I'll just kill the switch. And if anything goes wrong, I've got my fuse to guard the flow there. If whatever, something shorts out. So yeah, so playing it safe, and yeah, you can see. So I'll be able to test my temperature of my sand in here. So again, it's cold out. So we're gonna see what this does. I'm just gonna let it run for the afternoon. We're at, well, where are we at? 2 p.m., 1:32 p.m., I think. So our sun's already past our optimal for where I'm looking. I'm on the 53rd parallel. So, our latitude. You know, it's cold enough. It's not even melting the snow off the side of the panel. Yeah, a little bit. Anyway, so I'll check it in an hour, see what type of temperature we're getting out of the sand. Actually, I can do that now. Give you guys a shot. Get up there. All right, sand temperature is showing 0 on top, 1 degree in the center. I've got the electrode sitting dead center in the middle there. And again, this was sitting in the garage, and we've dropped down to temperature already. So it's pretty much environment temperature. So we're gonna see what happens here. And yeah, it's not sealed, it's not insulated, it's just a metal tin. Yeah, all right. All right, we are back with another test check, or checkup. We're at 4, I think about 4 o'clock up where I'm located, and temperature check shows, I really can't see my phone, so I have no idea if it shows this. So the side of the extra in the sun side is 36, 37 degrees Celsius, which is a heck of a lot better than and the shaded side 17.3 of the container. Down low, 3, 0 right down low. So I gotta get my electrode lower down. And up here there's no stuff there. So 12, 14. Again, so the switch is working fine. Let's see what temperature it might be running. -7, -8. So the switch is not even heating up. So that's great. So it does just fine carrying the current. I wasn't sure how it would respond to carrying 12 volts. So I did research and they said totally fine because it's a 120 volt switch and you're running less power than that. So you're totally fine. The fuse -8, -9. So it's good. All right. Yeah, she's nice and toasty, man. That's like a summer day. That's awesome. Let's open this guy up. Fold the one down. There we go. Okay. So our sand here, 28, 30, 31, right up above where the element is. 29, 18, 20, 20, 20. So that sand is warm. Let's give it a little bit of a dig. Woo, woo, there's steam. Okay, a little too much. And this is moist right now, so my sand isn't completely dry. It performs better when it's drier, they say. So we are 35, right near the element. It's 42, and you can see the steam, I think. So that 18 to 20 wasn't steaming off, but once I dug that down, it started to steam up real good. Now let's turn this up a bit. Let's get some of this moisture up here so it can dry out. So yeah, when it cools down and I shut the system off, or once it hits its temperature max that I want it to get, not sure how high to go yet. If I just want to see what it can get to, I guess, is what I'm really after. If I can get it up to 200 or something like that, that would be fantastic. So yeah, she's a good start, quite safe. And then with my tabs bent in like this on this metal lid, I'm able to use the handle to keep the lid on and not screw up with my wires too much, so I'm not doing any gashing or whatnot. And yeah, keeps it a little bit more secure, so no wind's going to be lifting that off. And we'll see what it looks like. I guess when the sun stops hitting the panels, I'll be able to tell, because I've got 10 panels running on another test I'm doing for the inverters and charge controllers. And my app will tell me when the sun's no longer feeding. That rock's going to block some of the sun, I think. Move that. Okay. And yeah, so there we go. A little more update. Again, my videos are a little long, a little chatty, a little slow, but I hope this helps guys who are looking into this, because it's a lot of research. Okay, our sun is gone. And back to the battery. Temperature check. All right, well, there we go. 5, 7, 8 degrees. 2, 1 degrees. A little bit of noise here. It's cool on top. I'm not expecting to hold too long because I don't have it insulated. Oh, there we go. Yeah, way down there, there's some temperature. Dug it down that far. 16, 15. Yeah, so it doesn't hold very long, obviously. I mean, I'm fully exposed in minus. I think we're -5 right now, -5 or 6. So, of course, it's not going to fight out with just this light metal tin and resist the cooling process. So, same as the heating, the better insulated I make it, the better it's going to be. So, I'm going to let it run tomorrow and just, we got some frost buildup. Clearly my humidity in my sand is pretty high. So that's giving it a definite bit of wash. All right, well, we'll test it out tomorrow. And I should probably clean my panel up too, just a little bit of smudge. These have been sitting while I got my system designed for my solar, so just, yeah, cool. All right, so we are at super cold. It's minus 15 Celsius. Loud beep from the temperature. Ooh, minus 30 on the bin. That metal holds the cold. I just had it open and it was reading minus 26 on the sand. So all sides are the same right now. And it is 9:30 in the morning. And yeah, so once the sun comes around, we'll see if she heats. Gets lots of shading at this location right now. So let's see what it looks like when we get back this afternoon. All right, here we're back again. Got a good sunny day, no shadowing. So it's been running since the last I do, 9 o'clock, 9:30. And yeah, she's nice and warm. That's good. Backside's cool, so the sun is definitely warming this the gray metal. It's just kind of dug it open a little bit. So let's see what we've got. So it's minus 9 right now, Celsius. We are, where's my light? 25 degrees, if you can see the light right beside the black wire. 65, 63. Down here, 0. Over here, minus 8. Okay. Let's do a little digging. Swap that up. There's that steam. Let's get deep and stay away from it. Ooh, yeah, we got lots of steam coming. Quickly before we lose our temperature. 25, 33, 93, 138 around here. 146, right up close to the element. We got 146 degrees. Okay. So, yeah, here we go. If we get this, get some insulation around this thing, it will definitely be able to create some serious power, some serious heat. So I don't know how much I'm going to run this. I guess I'll just run it for the day and see where it gets to by midday if it warms up more. I think we're getting to maybe minus 5. But see what it's doing to the sand. There was also black sand there, so I'm not sure what's happening there. That was all not black. But yeah, more testing. So pretty cool. All right. Here we are with blender number 1, learning the temperature limitations of the components. All this black stuff is the plastic molding at the top of the elements. That used to be a nice, beautiful little box up on top of the containing everything here where the screws would screw into. So clearly this element is toast. It was just running at 268 degrees Celsius. I didn't video that because once I saw the issue, I very quickly, well, I had already turned off my switch when I dug down to the surface to see what was going on, and the sand was turning black, which didn't make any sense. When I kind of churned it up a little, you probably saw in the previous videos. So blender number 1 is make sure you have a fuse, which it didn't blow because it actually didn't short out or anything. But so I beat it to it. The insulation wiring, yeah, it didn't hold out either. So clearly it's, I think this is 75-degree wire, maybe for internal wire temperature. But the insulation on the outside maybe is 115 or something. But it was holding out against 200 and some degree wire. Holding out. It was going to fail over time and just continually expose my wires even more and more. Thus, you know, eventually the wires could get moved, shifted, touched, whatever. The element itself is, it's handling the sand interaction well. It might have just speed cooled a little too quick because when I pulled it out, these electrodes, the arms were quite flexible. Just me trying to get the tape off, the electrode arms were bending quite efficiently. So anyway, yeah, yeah, you know, the beauty is I was able to kill my switch, which is easy to accidentally reactivate. So, you know, just pulled my fuse, and then we have no continuity, so I'm not in any danger of getting zapped. I'd have to connect up to the again, I mixed my wires up, so this is actually my positive wire, not my negative. I put the wrong MC4 on the wrong wire. So, which is okay. I said before, I just taped the end of the wire so I'd know which one was the positive and negative, and the MC4s only connect one way. It's just when you go connect it up at the other side, I have to make sure my fuse is on the positive line. So I used a red moret, and that, again, one more reminder to me, I didn't have any more of the pins that go inside of the MC4 connector. So, you know, just making sure I connected the right wires to the right point, because you don't want to flow the wrong way and your fuse doesn't work properly on your negative, because the power is now going back to the panel and you want to catch it before it gets to your device. So it didn't blow, it's in my pocket, but I pulled it out to kill the circuit for sure, so I'm not in danger on any point on this side. And a lot of folks will know that, but some people who are new into electronics and stuff, you got to make sure you cover your butt. Yeah, so that destroyed it. Yeah, so I might do a dip at the electrode itself. The element is actually fine, but you know, clamping back onto that's going to be a nightmare, so it's probably done. I would be willing to connect it myself, get this mounted on the outside of the thing, drill it in so this outside part stays out of the heat, basically, and it gets threaded in through the wall of the whatever container I'm going to use. So yeah, some more design options to run with, but there we go. So the temperature inside the sand, I think I said earlier, was 143. It had climbed up to 176. So it was hot off of the top of the electrode. Of course, that was 268 or 80. So it was piping hot. The sand around that area was warm. Down here was, you know, up in the dug into the sand, was pretty warm. I still have the sand, so I'm going to go dig into it, take some measures of that alone, just in the bucket. It's in the garage now. So, all right. So blender number 1, play safe, use your fuses. All right. So sand. Just the surface here. It's always a loud beep. 53:49. I just moved it in here about 5 minutes ago before I went back to the panel and showed you the element. Yeah, 36 degrees, 40 degrees, 55. Let me get a little dig in here. Ooh, that's warm. Ooh, yeah, that's hot. 63, 65, 72. Yeah, so it's still down in the main belly down there. It's got to be holding some nice, probably 100 and some degrees down in the center of it. And yeah, it smells like burnt plastic. So, all right, again, stupid move by just running putting that whole thing in there. And the outside of this baby's beautifully warm. Yeah, that's awesome. So what I'm going to do is I'm going to place this just directly into the chicken coop tonight, and let it just emanate the heat off. And as it cools off, whichever. I might pull a lid, but the chickens will probably want to play in it, so I won't most likely do that. Yeah, it'll work, but you got to build it right. Sweet. All right, here's our damage. Cleaned it up, got the isolators bottomed out again, contacts cleaned up, so now it's still usable, it still operates, it still has the same resistance. This is the part that burnt off, basically, so stupid of me to put that in the heat. Not really knowing how hot I was going to get, how fast. So yeah, all of this plastic body here, it basically melted away. Crumbled up into nothing and exposed all of the electrode arms. So what I'm going to do is I'm going to use 600 degree Fahrenheit Loctite, and I'm just going to isolate all the insulate the spaces. So just going to fill all the bottom in here, leave a little bit of the screw hole opening so I can get my screws in, and then just build up in between here with Q-tip. just to help it isolate. And then, yeah, there won't be any transfer of electricity between that through the gasket maker, so that's good. And yeah, standard high temperature gasket maker, 600 degree Fahrenheit, max -50. Had to go to the website to find it. Doesn't say it on the actual manual, which is a little mental. But yeah. Oh wait, there it is. Says it right there. 600 degree Fahrenheit, 316 Celsius. So I'll have to monitor that. Just keep an eye on it, and I won't have it that fully embedded. Again, any of that heat rises is going to rise into this anyway, so I'll have to keep my temperatures under 316. All right, see how it goes.